This recording deals with probably the most famous equation in physics these days, what we call the mass energy formula. What that equation gives us, it was the equation that was suggested by Einstein last century. It says that E, the amount of energy associated with mass, is equal to the mass times c squared. E is equal to mc squared, where c is the speed of light in vacuum. Okay, now this is the mass energy equivalence. Whenever we have an amount of mass, we can find its energy equivalent this way. Unfortunately, we usually cannot convert mass into that much energy. We usually convert just a very small portions of mass into energy. That's the basis of nuclear power plants. In nuclear power plants, what happens? You have large atoms that break in what we call radioactive decay, and when we get them to break, some of the mass that was making up these big atoms is going to change into energy, and that's what we capture as heat and so on. And that changed mass is going to change according to energy, according to this expression, E is equal to mc squared. Now, this is also the basis of fusion, or the process with which we get energy from the sun. In that case, it's the opposite process that happens, is you have two essentially hydrogen nuclei, two protons kind of colliding into each other and fusing, making a bigger nucleus, which is going to be, remember, a hydrogen nucleus is just a proton. So two protons, when they are going to combine, they are going to make a nucleus of what's called the helium atom. Now, in that fusion, in that combination, they are going to, the combined helium nucleus is going to have a lesser mass, and the difference between the mass of the helium and the two hydrogens is going to come off as heat, and the amount of heat is given by that expression. The difference in mass times c squared is equal to E, the amount of energy released. And we are thankful to that. Okay, we are not going to use this equation for solving any motion problems, but it was worth talking about it a little bit since it is a famous equation. We'll work an example dealing with it here. Let's say if we can convert the whole mass of a 1 kilogram delicious melon into energy, how much energy would that be? Now, E is equal to mc squared. Now, m is 1 kilogram, c is 310 to the 8 meters per second. Now, this is squared. So what we have here as an answer is 9 10 to the 16th joules. That's quite a bit. Now, we talked before about kilowatt hour. We said a kilowatt hour is 3,600,000 joules. So if we divide the amount there that we have, 9 to the 16, divided by 3,600,000 joules, what do we get? That gives us 2.5 10 to the 10 kilowatt hours. Okay, that's quite a big number. We normally in the US here, we use something like 500, 600 kilowatt hours per month. Let's say 1,000 kilowatt hours per month. So if it is 1,000, that means this allows 2.5 10 to the 7 households to have electricity every month. 2.5 10 to the 7. That's 25 million houses. So that Malon will power 25 million houses with electricity for a full month if we can convert all of that mass into energy.